Let's do the question number 32, which is the analysis of a water sample produces the following results. They have given calcium, magnesium, sodium, potassium chloride, sulfate and bicarbonate. The total hardness of the water sample. See, we know that hardness is created by the multivalent cations. So the only multivalent cations in this question are calcium and magnesium. These two cations are single valency and these are anions. So hardness will be created by calcium and magnesium. Now for calcium 2 plus, they have given the concentration 60 milligram per liter, and its equivalent weight is also given, that is 20. So equivalent weight is equal to 20 milligram per milliequivalent of the ion. Okay, and for Mg2 plus, they have given concentration 36.6 milligram per liter and its equivalent weight is equal to 12.2 given. So if we want to calculate the milli equivalent of calcium and magnesium ions, so milli equivalent of calcium and magnesium ions will be Ca2 plus. Milli equivalent is nothing but we need to divide the concentration by the equivalent weight. So that is 3, and for Mg concentration is 36.3 divided by 12.2. 36.6 is the concentration, so it becomes 3. So total hardness we have to give in terms of milligram per liter as CaCO3. So it will be milligram per liter as CaCO3 will be equal to milliequivalent of calcium plus milliequivalent of magnesium, milliequivalent of calcium plus milliequivalent magnesium, and it will be multiplied by the equivalent weight of CaCO3, that is nothing but, so milliequivalent of calcium 3, this is also 3, into equivalent of CaCO3 is nothing but the atomic weight divided by valency, 100 divided by 2, that is 50. So it becomes 50 into 6 is 300 milligram per liter as CaCO3. So the answer will be 300 is the answer. This question came in GATE 2017 for shift 2. Now the next question is also similar, but they have given the values in milliequivalent per liter directly. See, in previous question, that means in question number 32, we calculated the milliequivalent per liter, that is 3 and 3. Here they have already given milliequivalent per liter, like 2.65 is the calcium milliequivalent, this value, right? For magnesium it is 4.1 minus 2.65, that is magnesium equivalent. Now I need to calculate the non-carbonate hardness in this question. In previous question we had to calculate total hardness, now we have to calculate non-carbonate hardness. So for non-carbonate hardness, first of all we need to know what is the carbonate hardness, because total hardness is nothing but carbonate hardness plus non-carbonate hardness. And if we want to calculate non-carbonate hardness, we need total hardness as well minus carbonate hardness as well. And carbonate hardness is nothing but the removable hardness, that is from carbonates and bicarbonates. So, or we can say alkalinity or total hardness, whichever is minimum, right? So first of all, we need to calculate the total hardness. So total hardness will be equal to calcium milliequivalent. So we know total hardness is nothing but calcium milliequivalent per liter into equivalent weight, just like we did. So calcium milliequivalent is nothing but 2.65. I'll write whatever is given here first and then we will do the question. So for calcium 2 plus, they have given 2.65. So for calcium it is given 2.65 milliequivalent per liter, and magnesium 4.10 minus 2.65 will be equal to 1.45 milliequivalent per liter, right? And sodium also we can just do the minus of 6.35 from 4.1, right? But we don't need sodium and potassium and sulfate and chloride. We don't need that. We just need, and for alkalinity we will be needing SiO3 minus, that will be equal to 3.3 minus 0, 3.3 milliequivalent per liter. Okay, now we can calculate total hardness. Total hardness will be equal to, by the multivalent cations, so calcium is 2.65 and magnesium is 1.45 into 50, right? 2.65 and 1.45 into 50. So if we calculate total hardness, it comes as 205 milligram per liter as CaCO3. Now this total hardness is there in option, 205 milligram per liter as CaCO3. If in hurry we tick on this because we got some answer, then it will be wrong. So for that we need to be cautious before ticking any answer. So this is total hardness. Now we want to know total alkalinity, because I need to check carbonate hardness as well. So total alkalinity will be SiO3 is 3.3, right, into 50, nothing but 165 milligram per liter. Now this is also in option here, option B, but this question is still not completed. Now carbonate hardness will be minimum of total hardness or total alkalinity, right? So it will be, carbonate hardness came as minimum, that is 165 milligram per liter. Now non-carbonate hardness is simple, that is total hardness, which is 205 minus carbonate hardness 165, equal to 40 milligram per liter as CaCO3. So the correct option is option A. This is the answer, right? Okay, let's move on to next question, which is effluent from an industry A has a pH of 4.2. The effluent from another industry B has double the hydroxyl ion concentration than the effluent from industry A. pH of the effluent from the industry will be industry B, they are asking. So let's do the question next. So here the term pH came. pH is nothing but is the measure of the potential of hydrogen ion concentration. So when any substance dissolved in water it dissociates in water either in terms of H plus ion or OH minus ion. That means I am saying that if any substance, so the water will be broken into H plus ion plus OH minus ion. So when any substance dissolves in water, it dissociates in water either in terms of H plus or OH minus ions. And we know that the H plus ion concentration multiplied by OH ion concentration is 10 to the power minus 14 moles per liter. If we take log on both sides, we get log 1 upon H plus ion plus log 1 upon OH minus ion is equal to 14, right? And from this we get, this is nothing but pH. So from this we get that pH plus pOH is equal to 14. This is the main idea behind how pH and pOH comes to be 14. So this is the formula where pH is nothing but log of 1 upon H plus ion concentration. We can simply say minus log of H plus ion concentration, right? And similarly pOH is nothing but log of 1 upon OH minus ion concentration, that is minus log of OH minus concentration. Now this is all about the theory behind the question, right? These are the basic ideas, basic question, we can say the concepts behind the question. Now in this question we have given that the effluent from an industry A has pH of 4.2, effluent from another industry B has the double the hydroxyl ion concentration than the effluent from industry A. So they have simply said that the OH minus of effluent from industry B is 2 times the OH minus of A. So we can simply say OH minus of B is 2 times OH minus of A, right? And they have given the pH of industry A. So pH of, we can say, A is 4.2. Okay, that's good. Now that we know the formula, pH plus pOH is equal to 14. Okay, so pH of A plus pOH plus pOH of A will be equal to 14, right? So by that we can say pOH of A is equal to 14 minus 4.2 and it comes to be 9.8, right? Okay, now this is what pOH. pOH is nothing but minus of log OH ion concentration. Just now we have seen this. Okay, that is nothing but 9.8, right? Now OH minus concentration is nothing but, we can take antilog both side. So it is equal to 1.5898 into 10 to the power minus 10 mole per liter. This pH will come into mole per liter. Now we know that they have already said this thing, that OH minus concentration of B is 2 times OH minus concentration of A, right? So So this is for A. This was for A. So OH of B is equal to 2 times of 1.5898 into 10 to the power minus 10, that is 3.6196 into 10 to the power minus 10. Also, and when we have OH ion concentration, we can simply find the POH, that is log of 1 upon 3.6196 into 10 to the power minus 10. So POH of B comes out to be 9.5. And they are asking about the pH of effluent from the industry B. Simple. Now we have POH of B. So pH of B is nothing but 14 minus 9.5, that is 4.5. This is the answer. So I can simply put out the answer as 4.5. Next is question number 35. A water sample has pH of 9.2. The concentration of hydroxyl ions in the water sample is C. Just now we have done the question number 34. If we have done question number 34, 35 will become easier, right? So let's do this. Concepts are same. So see, let's try question 35. We have given the pH of the sample. pH of any sample is 9.25. And we know pH plus POH is nothing but 14. So POH is 14 minus 9.25. It becomes 4.75. Now we want to know concentration of hydroxyl ion. POH we got. So POH is nothing but log 10 of OH minus concentration, and from here we can simply say that OH minus concentration is nothing but 10 to the power minus POH, right? So it becomes 10 to the power minus 4.75. moles per liter, right? This is OH minus ion concentration. Now this is an option, that is option number B, but first we need to see that it is also in millimoles per liter, not moles per liter, and this is wrong, so this is also wrong. Remaining options are C and D. Let's check. Let's solve it further, and we get moles per liter concentration they are asking. Now the option is in milligram per liter. Milligram per liter, let's change it into milligram per liter. So for milligram per liter, that is nothing but this equals to mole per liter into molecular weight into 10 to the power minus into 10 to the power 3. Molecular weight into 10 to the power 3. This is the thing to change. Milligram per liter is equal to mole per liter into molecular weight to 10 to the power minus 3. 10 to the power minus 4.75 moles per liter. Molecular weight of OH minus ion is 17 to 10 to the power 3. It becomes 0.3028 milligram per liter. So the option is option number C. This is the answer. Let's do the common data question number 36 and 37. iron concentration obtained for a groundwater sample having water pH is 8.1 and the iron concentration of calcium, magnesium, sodium, bicarbonate, sulfate, chloride is given. Iron concentration in milligram per liter and their atomic weights. Now, the question number 36 is total hardness in the above water. 37 is carbonate hardness. Let's do. We have been doing these type of questions. So for now, this will be easy for us. So total hardness is nothing but it will be by calcium and magnesium because they are only the multivalent cations. So calcium ion concentration is 100 milligram per liter, right? So we need to divide it by, first of all, its molecular weight and valency equivalent weight we can say. So the equivalent weight is 20 and if we multiply it by 50 it will give us the milligram per liter as CaCO3 plus magnesium is ion concentration 6 divided by 12, it is 24, so half of 24 is 12 into 50. So the total hardness is 275 milligram per liter. So the correct option is option number C. Okay, let's move on further. Next, 37. Carbonate hardness they are asking. Carbonate hardness will be because of the total hardness is 275. Okay, now alkalinity, first of all, let's calculate. We can say total alkalinity is equal to alkalinity, it is 250 divided by its molecular weight, equivalent weight, that is nothing but the atomic weight only. So 12 plus 16 plus 1 is 61. Oxygen 3 are there, so it will become 61 into 50. This is 205. Carbonate hardness is minimum of these two, total hardness and total alkalinity. So it is 205. So the answer will be 205. Now let's do next common data type questions that are 38 and 39. Following chemical species were reported for the water sample: chloride, sulfate, carbonate, bicarbonate, calcium, magnesium and pH. For total hardness we need calcium and magnesium. For alkalinity present we need carbonate and bicarbonate. Let's calculate. So the hardness, and see here they have already given it into milli equivalent per liter. So for milli equivalent we simply multiply it directly by the equivalent weight of CaCO3. So for calcium we need to calculate total hardness. So calcium is, they have given 12 into 50 directly. Magnesium they have given 18 into 50 directly. 12 plus 18 is 30. 30 into 50 is 1500 milligram per liter. Okay, so this is total hardness. 1500 milligram per liter is the answer. Now they are asking about alkalinity. So alkalinity is created by, total alkalinity is created by carbonate and bicarbonate. Carbonate and bicarbonate, so total alkalinity will be equal to, carbonate is 5 into 50 and bicarbonate is 30 into 50. So that is 35 into 50. So that will become 5 into 50 is nothing but 250 and 30 into 50 is 1500. 1500 plus 250 is equal to 1750 milligram per liter as CaCO3. So the answer correct option will be option C, 1750. So see, this type of question came for 2 marks. If we know the concept, this will just save our time, right? So the next question, which is question number 40, states that a wastewater sample contains 10 to the power minus 5.6 millimoles per liter of OH minus ions at 25 degrees Celsius. The pH of the sample is, we need to calculate what is the pH of the sample. See, they have given us POH, right? POH is nothing but minus of log OH ion concentration, right? And this, where this OH ion concentration will be in moles per liter, right? Now, okay, we have given the OH ion concentration, that is 10 to the power minus 5.6 millimoles per liter. See, we need to put concentration in moles per liter, but they have given the concentration in millimoles per liter. So first of all, we need to change it into moles per liter. So that will nothing be but 10 to the power minus 5, milli means 10 to the power minus 3. So now it becomes OH minus concentration is 10 to the power minus 8.6 moles per liter. So this is the concentration. Now we can calculate OH ion concentration. OH ion concentration is nothing but minus of log of 10 to the power minus 8.6, that is equal to 8.6, right? Now pH is 14 minus 8.6, that will be 5.4. So the answer will be D, 5.4. Now let's see what is the next question. Next question are the two linked answer questions. First one, so the theory about this is a water contains the following dissolved ions: sodium, calcium, magnesium, aluminium, bicarbonate, chloride. Water pH is 7. Atomic weights are given. Total hardness of the sample in milligram per liter as CaCO3. All questions are asking the same thing, right? Till now we know how to calculate the total hardness. Total hardness will be created because of the multivalent cations. So the multivalent cations here in the question are calcium, magnesium and aluminium. Calcium, magnesium, aluminium. Right? So the total hardness will be created because of this. So the total hardness will be, and they have given it into milligram per liter. So the total hardness will be calcium ions millimole equivalent per liter as CaCO3. Okay, so we can say equivalent weight, we can simply say for calcium it is 40 and the equivalent weight of calcium is 20 into the equivalent weight of CaCO3, that is 50. For magnesium, the magnesium weight is given 30 milligram per liter and they have given it is 24 divided by 2 will be 12 into 50 plus aluminium is 3 milligram per liter divided by 27 divided by 3 will be equal to 27 divided by 3. Okay, then it will be into 50, right? So the answer will be, it comes approximately 241.67 milligram per liter as CaCO3. So the option which is very close to this is 242. Let's do next question, that is for non-carbonate hardness of the sample. Now non-carbonate hardness, for non-carbonate hardness, first of all we should know what is carbonate hardness. And carbonate hardness is nothing but the minimum of alkalinity or total hardness, and alkalinity is by bicarbonate ions. So we need to get the bicarbonate ions alkalinity. Total alkalinity is nothing but bicarbonate 190 divided by its molecular weight, that will be equal to 61 into 50. So it comes as 155.73. We can approximately say it as 156 milligram per liter as CaCO3. Now, so the carbonate hardness is minimum of 156 and 242. So the carbonate hardness is 156 and non-carbonate hardness is 242 minus 156 is equal to 86. So the answer is option C, 86. This question 43 came for 2 marks in GATE 2005, which states that the tomato juice is having pH of 4.1, the hydrogen ion concentration will be. See, pH is given, that is 4.1. Hydrogen ion concentration will be, H plus ion concentration will be nothing but 10 to the power minus pH, and that is 10 to the power minus 4.1 moles per liter, and that comes to be 7.94 into 10 to the power minus 5 moles per liter. So the option is option D. Next is question number 44. A standard multiple tube fermentation test was conducted on a sample of water from a surface stream. The results of the analysis for the confirmed tests are given below. They have given sample size, number of positive results out of 5 tubes, number of negative results out of 5 tubes. We check number of positive results, right? MPN index and 95% confidence limit for combination of positive results when 5 tubes used per dilution 10 ml, 1 ml, 0.1 ml. Combinations of positive 421 and 431, right? Okay, so see, using the above MPN index table, most probable number of the sample is, see, this given here is a standard size, standard dilution, standard combination, and this is the sample that we have taken that has this value. Now the sample size given is 1 ml, 0.1 ml and 0.01 ml. This is the sample size. Whereas the standard size should be 10 ml, 1 ml, 0.1 ml. And the combination that matches with the sample size and the standard size is 431. So the standard size is 10 ml and sample size is 1 ml. We can clearly see that the standard size is 10 times more than sample size. size, right? So the MPN index per 100 ml is 33 for sample 431. So because standard size is 10 ml, that is 10 times more, so the sample MPN should be, sample MPN will be 33 into 10, that is 330. So the correct answer is option D. Question number 45. The results of water sample analysis are as follows. Cations and concentration and equivalent weight is given. Now we need to calculate the hardness. Hardness is nothing but, we know right now. Total hardness is calcium ions concentration divided by equivalent weight or into equivalent weight of CaCO3 plus same for magnesium ion. Other two cations are single valent, so these are not creating hardness. Calcium ions concentration is 40. Its equivalent calcium ions concentration given is 55. Its equivalent weight is 20 into 50. Plus magnesium ion concentration given as 10, its equivalent weight 12.2 into 50. So the total hardness comes to be 137.5 plus 40.98 that becomes approximately 178.48. So the total hardness comes to be approximately 179. So the correct option will be option number C. Let's see the next question, which is calcium concentration and magnesium concentration of water sample are 160 milligram per liter and 40 milligram per liter. Total hardness, again we need to calculate total hardness in terms of CaCO3. So the total hardness here will be calcium ions concentration 160 divided by equivalent weight of calcium into equivalent weight of CaCO3 plus 40 divided by equivalent weight of Mg, we can take that as 12 into 50. So the values will be 80 and 400 plus 166.67. So this is 566.67, approximately 567. So the correct answer will be option D. Now the last question that we are going to do in this chapter is two samples of water A and B have pH values of 4.4 and 6.4. How many times more acidic sample A is than sample B? See, sample, we need to just check the ion concentration. So sample A, pH of sample A is 10 to the power minus 4.4 and pH, okay, this is the concentration of hydrogen ion is 10 to the power minus 4.4 mole per liter, and concentration of hydrogen ion in sample B is 10 to the power minus 6.4 mole per liter. How many times more acidic the sample A is than the sample B? So sample A concentration for sample A divided by concentration of sample B. They are checking. Sample A concentration is 10 to the power minus 4.4 divided by 10 to the power minus 6.4. So 10 to the power minus 4.4 is equal to, this is 10 to the power minus 4.4 plus 6.4. It comes to be 100. So the answer will be C, 100.